Hi everybody, this is an oscilloscope and we use it to measure voltages just like we use the DMM to measure voltages. The difference between an oscilloscope and the DMM, well, there are several, but the major difference is that the oscilloscope measures voltage over time and produces a graph for you. So time goes from left to right and voltage goes up and down. And so the oscilloscope has a scale for time. In this case, the time is 1 second per division. It means that each one of these major divisions is 1 second long. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions across. Therefore, it takes 10 seconds for the oscilloscope to write a line across the scope. And if I stop it, this part of the line represents the voltage now, and this part of the line represents the voltage 9 seconds ago. And there's a 1 second empty spot here. So if the voltage changes, the line will go either up or down. This little arrow on the left-hand side represents 0 volts. So if the line goes above 0 volts, let's see if I can make it go above, that's below. If it goes above 0 volts, it's positive. And because channel 1 is calibrated to go at 2 volts per division at the moment, the voltage we're seeing here is a little bit more than a volt. And if I can continue to go up, and that would be 2 volts. And I can continue to go up, and that would be 4 volts. And I can continue to go up, and that would be 6 volts, 3 divisions above 0, so 2, 4, 6 volts. And the voltage can go negative, of course. And so when it goes negative, it goes below 0 on the graph. And so this is minus 2 volts, minus 4 volts, and finally minus 6 volts. And the oscilloscope screen contains a history of what I've done over the past 9 seconds. Now generally we use the oscilloscope to see faster events. Right now I'm just looking at a DC voltage, but we can look at faster signals. In computer science we like to look at pulse trains, and let's see if we can't find one. So to see this pulse train, I've got to speed up the sweep. And you can see it's still not fast enough to capture the pulse train that's on there. And then finally, as I decrease the amount of time it takes for the line to go across the screen. So now the time base is set to 1 millisecond per division, which means we have 1 millisecond from here to here. And this waveform repeats every millisecond, a rising edge, a falling edge, and then 1 millisecond later, a rising edge, half millisecond later, a falling edge. So this is what we would call a square wave. And sometimes we want to see things that are even more complex than this. So for example, the human voice. So I've connected this microphone to channel 2. So I'll turn off channel 1, and turn on channel 2, and then turn on the microphone. And now you can see what my voice looks like. So those are all the little waves that make up my voice. And we can try to capture just a piece of this by doing something called triggering. So I need to change the trigger source to channel 2, and now you see it captures for a brief period of time a portion of my voice. I can increase the amount of time it takes to go across, for a word to go across the screen, and now we're capturing almost one word at a time on the screen. And I can make this so that we can just capture one word by asking it to simply stop acquiring data after it catches one. One. So there it captured my voice saying one. And we're going to go a little bit deeper into how this oscilloscope works now.